Uranus is sucking back. Uranus is sucking back. Why? I don't know. How can Uranus suck back in? I can't get off that. Hello everybody, what's going on? I'm Player, and I'm going to be playing Universe Sandbox again. I played this once before. I kind of rambled in that video. It's a very old video too. I haven't played this, and I played this in my own time, but I haven't played this for you guys again. I'm playing it again because I just thought it would be something interesting to play, and I really like space. So yeah, let's just get into what I wanted to do. What I wanted to do here is take if I can open up the menu for it. There we go, okay. I wanted to take the sun and see what would happen if I... Wait, I don't want to lock the sun's mass. I want to make it bigger, but I want it to keep the same size. You know what, why not? Let me just make it bigger, okay? I'm going to make it bigger by 1.50. Let's see what happens to everything around us, okay. Ooh. Okay, everything is going in more. Earth is probably going to be vaporized since it's closer to the sun. Oh, Earth and Venus almost collided. Let me zoom into Earth. I think. Is Earth hotter? Yes, it's 32 degrees Celsius. It's usually around 15. It usually stays around the 15 marker, goes up and down. But, yeah, it's 32 degrees Celsius, and it doesn't look like it's burning up. If you don't know what Universe Sandbox is, it's a realistic space simulator. It's a space simulator where you can do a bunch of different things. You can watch galaxies collide. You can do pretty much almost anything. I mean, they've got a lot of tools here. You can add stuff. You can add objects. You can... tools, yeah, you can pole switch, launch a ring or sphere of particles at a set velocity. Okay, I've never done that. There's force. I've tried force. It doesn't really do anything for me. If I go to force, watch, see, it does this stuff, but I don't see it doing anything. See, nothing happens. Everything stays in its own place. There's fireworks. Hang on, let me see what those do. Okay. It's probably because you have to do it on a body. Yep. Yeah, and I think I just destroyed Mars. So, you know, we don't have that anymore. There's also materials. You can put hydrogen, carbon, water, silicate, iron, anything you want, and you can launch them into whatever you want. Space, a planet. If you launch it correctly, because I launched it at it, and as you can see, it's not going towards the planet. You can adjust the particles per second, the spread. It will get CPU intensive if you try to increase the time too much, because if I go and let's see if I can get rid of this, which, can I get rid of this? Yes, I can. Okay. Now, oh, timer. Okay, I've never seen that. Advanced time. That's new. That is new. They have updated this game, and they do keep continuing to. What I want to do is I really want to play this in VR. It would be so awesome to play in VR, because I've seen you can put on the VR headset and then look around and start messing with planets and stuff with the controllers, like you're moving it with your hand and stuff like that. It's so freaking cool, and plus you're in VR, can't see anything around you or anything except the space and everything. It'll be freaking awesome. But I'm not that rich to be able to get that, even though I really want it. I've been wanting that for a while. I wanted to try VR for a while, but yeah, I can't. So I'm content with what I have right now. But anyway, as I was going on about, as I was gonna do is show you that if I speed this up, see how it gets in the red? That means the CPU can't handle the, it starts, the faster you go, if I go into here and show you guys, if I open this up. Okay, I can't find it, but it will tell you somewhere that, ooh, okay. It will tell you somewhere. I saw Venus, like, okay, once it goes around a certain part of the sun, it starts heating up. But back to what I was saying, I can't find the settings in there, but in the settings somewhere, it will tell you that if you increase if you lower or increase the calculations, the faster the speed goes, the less accurate the calculations are for realistically how space would work with particles and planets and everything like that. Okay, that's weird. If you saw that right there on the Earth thing, let me see. Yep, it does. If you're watching Earth, man, let me slow this down. When it goes around the sun, it loses all of its oceans, and then it gets them back. It literally like kind of vaporizes the planet, and then it kind of it's back and it's fine. So, hey, wait a minute. Let's see the water. Let's see if the water comes back. Yeah, it's starting to decrease very fast. The temperatures. Oh, I didn't get to see it. Oh, damn it. I'm going too fast. Way too fast. I want to see it come back. Ah, come on. I'm trying to do it correctly. Okay, come on. Come. Ooh. Okay, it's decreasing now. Damn it. Oh, now it's decreasing. Okay, just a little bit faster. A little bit. I don't want to do it too fast because I don't want to miss it again. Oh yeah, you can see it right there. Some of the oceans are coming back. I don't even know how that's possible. If all the water is evaporated, how does it come back? I guess it stays around the atmosphere, I guess, until it's cold enough to drop and come back. So, hey. But yeah, there's that. So apparently I kind of ruined all that, and I ruined all the orbits. Let me see what happens if I turn the sun down to not even its normal size, 0.50. Whole mass down. Now it's a Jupiter. It's 524 Jupiters, and it's blue. So because I made it smaller, it turned blue. Okay, don't know how that works. I don't know if that's realistic, but it's supposed to be a realistic space simulator. So you know. But Earth decided to launch out. Goodbye, Earth. Goodbye, all the planets. Mercury and Mars almost collided. Did I actually destroy Mars? No, I didn't. Just fireworks happened on it from before. So yeah, I think I destroyed everything. Then I think I can get everything all sucked back in by, you know, making the mass 5 times. Five times the sun. Come on, 5 times the sun. Suck everything back in. No, the sun is not sucking everything back in. Turn your mass bigger, son. You need to go 200 masses bigger. Now everything's being sucked back in, but Venus is still leaving. Come on, Venus. You know you want to be sucked back in. Everything's being sucked back in. Uranus is sucking back in. Uranus is sucking back in. Why? I don't know. How can Uranus suck back in? I can't get off that. Again, how does the sun look now? Oh. Okay, I'm gonna restart this simulation. I'm gonna open an existing one. Oh, these are all new. Oh, there's some new simulations. Solar system planet comparison. Whoa, okay. There's Earth. See, we're kind of fucking small. Kind of insignificant to the rest of anything. Because Jupiter, insignificance to any sun. Hell, insignificance to our sun. It's like nothing. And then, where's our sun, actually? In comparison. There's actually a different comparison some way. Solar system planet comparison. I didn't even know that was there until just recently. Our solar system is home to 8 planets, 4 terrestrial and other planets. Yeah. Blah, blah, blah. I already know all this. Its diameter, wait, one large scale is Jupiter, the gas giant, more than twice as massive as all the other major planets. Yeah, it doesn't seem twice as massive as Saturn. I mean, look at the sizes. So, now it seems twice as massive as like Uranus and Neptune, but Saturn? I don't know if it's twice as massive. It doesn't look that way, but it could be, I guess. Has a diameter 11 times greater than our own planet. Pluto, dwarf. Moons in our solar system, including our own moon. Right click on them to explore object, more properties. Yeah, I know. I can always mess with them and destroy everything too. Could I? Yes, I can. But I'm not going to. I want to open up that other simulation too. I was gonna open up to mess with more with where is it? The solar system. Here it is. They got some new solar system. Oh wait, the solar system now and real time. Really? 28. Oh. Solar system now in real time. Here you can see the current position of objects in our solar system. The time set is set to real time, or 1 simulation second per real second. Our system is home to 8 planets. Yeah, we already know this. Blah 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 blah. Don't need to tell us that. But yeah, I've done this before. I've made the year and the time and everything exactly the same, and I set it to real time. Hey, if you let this run, you can actually see where you end up and stuff. I had to keep recording it, so you'd have to have like 50 billion terabytes of data. You know, you need a lot of storage to keep recording it so you can see it progress over time. Otherwise, you'll fill up your storage too fast. Otherwise, you have to have it really low quality so you can keep this file size to a minimum. But even then, recording a 50 to 100 hour file is going to take up massive amounts of space, even with minimizing the size of the video recording. So, you know, don't know how that would work out. It seems to be kind of like lagging. It's not smooth. I don't know. It might be just me. Oh, there's everything. There's everything that wait, what is that? Did Jupiter blow up for some reason? For like no reason? What the hell? Are you sure that's real time, dude? I don't know if that's real time. Oh! Okay, Jupiter has tons of moons, if I'm remembering correctly. That's why. Okay, that's why. It looked all weird for a minute, because there was like a bunch of crap around it, which I never saw before. So I guess they updated it to have all those moons. Okay. Okay. Potentially hazardous asteroid? Asteroids considered to be potentially hazardous. The minimum distance between the asteroid's orbit and the Earth's orbit is less than 0.58 U. The asteroid is larger than 100 centimeters across, and 17 potentially asteroid. This simulation shows only a portion of these. This is only a portion? Okay, that's kind of scary. So, you know. Vsauce. Oh, I remember that one. Okay, that was that Vsauce video where he explained about the moving with a heavier object and stuff like that. He was explaining stuff in one of his videos. I'll link that video because I didn't expect to see that. That's interesting. I never expected. Check out Vsauce. Yeah, see, check out Vsauce's video on YouTube for more in depth. It shows that gravitational force between an object is solely dependent on their masses and not. It's solely dependent on their masses and not their size. If their size is really small, but they have the same mass as the sun in the center, the orbits will still be exactly the same because it's the same exact density, the same exact. It's like if you were to take it's like if you were to take paper or something and you were to put a ball on there. There's a small ball, it feels heavier, but if you put it on there, it does the same thing as the bigger ball that's not as heavy to you. And you put it on there and they both do the same thing. It's because one's lighter, but it's bigger. But the other one's the same weight, it's just smaller, and that's why it feels heavier and it feels like more dense. If that makes any sense, you know, it's heavier but it's not heavier, and if that makes any sense, if I'm explaining that correctly, which I don't think I am, so Go watch his video. He explains it better. So. But, wow, that's so tiny. But yeah, see? I think that's, wait, done? Yeah, it is one sun, see? This size is one sun. Let me see if I can't lock the mass. Okay, you can see that happening. Come on, lock the sun's mass. How do I lock it? I don't know how to lock it. I'm an idiot. I'm retarded. I don't know shit. I didn't see that. God damn it. Okay, what I'm supposed to do is click on this, and then I can lock it. God damn it. God, lock it. So dumb. I need to know some more. I don't know how to play this. I'm so stupid. That's how you do it. Now I know how to do stuff. Yeah, I don't know how to do stuff. Anyway. Now I'm gonna do what I wanted to do. Okay? Okay, here we go. Now let me just make this bigger. Let's see how it grows actually. Make its radius bigger. It's not changing anything really. I'm making it bigger. I mean, as you can see. I don't even see the size really changing. Oh, yes, I do. Now I do. It's starting to get a different color. You can see that shade of color changing, and you can see it growing bigger and bigger and bigger. Okay, yeah, here we go. The size is really increasing now. And it really isn't changing anything. I mean, a lot of the planets are getting hit with more heat because it's expanded. But as you can see, the sun is way bigger than what it used to be, but the orbits of the planets have not changed at all. It has just become less dense, if I'm saying that correctly. And yeah, Earth is still kind of screwed now. You know, I can probably fix that if I turn it back to its regular size. You know. Let me shrink it back to where I'm gonna estimate where I had it before. I'm probably gonna be off. It's probably gonna be a bit bigger, but than it should be, but somewhere around there, I'm guessing. Did Earth like get its stuff back, please? Or did I kill everybody? I think I killed everybody. I think I'm a horrible, horrible person. Yeah, I think everybody's just dead now, forever. Until I, you know, revive them. I'm gonna go to where I was talking about that other simulation as well. Where is it? Physics. Wait, there were some new ones in the collision, I think. Wait, no. All? Where is it? There was some new one that I wanted. There it is. I remember that being new. Oh no. Yeah, I already clicked on it. That's why. I've already seen it. Vsauce do pace. Vsauce did that one too. Do two baseballs 1 meter apart. I never saw that. Wait, the simulation shows an object that all objects are gravitational force on each other, even baseballs. Notice how long it takes for the baseball to travel a total of 1 meter. And then they collide with each other and boom. Oh no. I thought they would have. Okay. 1 meter. Check out Vsauce's video. Blah, blah, blah. Yeah, I know. Let me go find that. History. No. Planets. Explosions. Collisions. Physics. Where did it go? Are you kidding me? Is it gone? Oh. It can't be gone. It can't be. I don't think they would just get rid of it. They did. They got rid of it. Those bastards. they got rid of it. I still like the game nonetheless. They got rid of the simulation I was trying to... Oh, no, there it is. They didn't get rid of it. I just couldn't find it because I'm dumb. I don't know. It's in collisions. That's where it would be. Okay. Okay, I'm just not looking because, you know, I apparently don't do that sort of thing. It's not in collisions then. It says it was a collision. Okay, whatever. Just I'm gonna go to where I know where it's at, and here it is. It's the galaxy collision right here. This is what I was looking for. It can show you a galaxy collision. 4 billion years from now, our Milky Way will collide with the other galaxy. If you pay attention to anything they're saying or whatever, if you know that. If you don't, well, now you do. If this is brand new information to you, for like a long time from now, we'll all be like long gone and forgotten by that time. But that's then, and this is now, so you know. But anyway, this is two galaxies colliding. I can speed it up, but it kind of ruins it. Because, so I'm just gonna let it go at its normal pace right now to show you what it's doing. I don't know if it would happen like this. I mean, they can only do so much with this simulator, with the simulation. I would assume there's like a lot of particles floating around right now, like billions, more than billions, trillions or whatever. So I don't know how that would, well, it's working fine on my system. I just don't know how well it would work on anybody else's system. But man, see how they're colliding? It's kind of cool how it creates, how it looks like that. If you look at it like from the side, from a disc perspective, making itself all 3D and it's swirling around. Now, if I were to restart the simulation, if I open up here, if I were to restart the simulation and I sped it up, you'll see that it gets incorrect pretty fast if you go too fast. I'm going to speed it up, and you're going to see, watch, simulation can't run with any faster. Okay, I can't show you that apparently. It refuses to let me. Let's see if it does mess up though with the fastest I can go, because with the new update, I don't know, they implemented, oh, I don't know what they implemented, but see how you can see that didn't happen before. Some got ejected, but they implemented something where it stops you from going too hard on your computer. But if you went fast enough before, a while ago, stuff would have just flown out everywhere, and it would have become like puffs of air everywhere, and it wouldn't have looked good. It would have just blew itself apart because the simulation wasn't acting correctly. Earth and 100 moons colliding. I think I've seen this before. Yeah, see, you can see the collisions, but they only create like a red mark. They don't create an actual indentation into the planet's surface. I mean, it kind of looks like it does, but from here, but other than that, not really. It just shows you a red piece, like creating another landmass, and then it gets covered by water. And I wish they would make the collisions like more 3D, you know, so it looks like the thing got hit, because if you were to hit a circular object with something that has enough force, it would dent it, or it would cause it to chip away, and it wouldn't look circular still, but it looks still circular. That's one of the only things I have a gripe with about on this game. I just wish the collisions would be more 3D, more realistic. Other than that, there's not much I really hate about this game. I really like this game. When I first saw it on I've had it for like a while now, but a long while, over a year. But when I first saw this game, I'm like, oh, I wanted it. It was only, when I got it, it was only 20 bucks. I think it was on a sale, or it could have been just the regular price. You'd have to look on Steam. It's on Steam. There is another Universe Sandbox, but it just says Universe Sandbox, and this one is Universe Sandbox 2. It's not really Universe Sandbox 2, but I don't know how you would name that, because it says Universe Sandbox, but it has, you know how they have those R logos in the corners of certain logos. It has like a small number 2 on the top right hand corner of Universe Sandbox. It doesn't say Universe Sandbox and then 2. It just says Universe Sandbox with a small 2 up in the corner. I think that's supposed to mean something different, but I don't know. But other than that, here's Earth at 500 degrees Celsius. Here's Earth at 1,000 degrees Celsius. I don't know why they put all this in, but Earth at 2,500 degrees Celsius. Holy crap! It's just a yellowish orange ball. It starts getting blue. 5,000 degrees Celsius. Now at 10,000, they keep doubling it. Now it's blue, and you can see gases coming off of it, and you can't even see anything on it anymore. At 20,000 degrees Celsius, whoa, major gases coming off of it. It's like evaporating the Earth. 50,000 degrees Celsius. 100,000? Yeah, 100,000 degrees Celsius. Holy crap. That's just a solid light blue ball. This one you probably want to be able to see really at all while you can until it starts in that 1,000,000 degrees Celsius. It's the temperature of the sun's 1,000,000 degrees Celsius. The temperature of the sun's corona heat to the Earth. Wait. Temperature of the sun's corona heat to Earth to this temperature. I can't heat the Earth to this temperature. I can't read for crap right now. 1,000,000 degrees Celsius is the temperature of the sun's cornea. Heat the Earth to this temperature and it will vaporize, leaving remnant of a few dozen more massive than the moon. Remnant will slowly cool as it heat is lost to space. I don't even know. Oh, it's been a while. It's been a while. Well, I'm gonna end it here, guys. I mean, I didn't expect to be recording this long. I expected this to be short because I just wanted to show a few things, and I got carried away. So as you can see, you know, I'm liking space and stuff. Well, anyway, thank you guys so much for watching. If you stayed this long, please let me know if you did, and I'll see you, and you'll see me in another video. Bye.